Okay, let's say that this is a robot. Now, it is an intelligent robot. Yeah, I'm kidding. But in this video, we will actually see how I train a robot for my Intelligent Robotics exam. And I did it using reinforcement learning to go from this to this. An autonomous robot that moves in unknown environments with moving obstacles and that can also solve mazes. To do that, I used Ml-Agents, which is a powerful tool to train agents in Unity. It will make you cry several times, but it will also make you smile when everything works as you want. First of all, I installed the package and Python. I installed Python 3.9.13 since I knew it was fully compatible, so I suggest you to do the same. Install it and make sure to add it to the path. Go into your project folder and type cmd in the path bar. Type this line, it will create the v1v folder in your project. Then, write these lines in the command window to install all the dependencies for Ml-Agents and you will be ready to train your robot. So, what we need for this project? An abnormal amount of patience. The reinforcement learning algorithm is based on trial and error. This means that the robot will try to reach a specific goal in an infinite number of different ways. And sometimes it will do in very strange ways. But if we understand what we are doing, we can get good results. And who said that I know what I'm doing?
That guy!
Who, me?
After hours and hours passed coding and studying the Ml-Agent documentation, examples, and the theory for my exam, this last one was for my professor, not only I ruined my eyes, but I also got what are the main concepts that you have to understand in order to properly train your agent. First of all, the agent is what you are training, and it collects observations, which are all the things the agent sees thanks to sensors. Decides actions, which are the movements it takes to reach the goal. Receives rewards, which are like saying good job or not to the agent. Then there is the policy, which learns which actions gives the best rewards based on the observations. And we define all of these in the agent script using these methods: collect observations and on action received. In my case, I train 3 different agents with increasing levels of modeling complexity. Let's look at the first one so you can create something similar as a starting point. This robot only takes as observation the distance to the goal and is rewarded at each step based on how close it is to the goal. My suggestion is to don't give too many observations and always normalize values, which means the values should be between 0 and 1. But that's not very interesting, it only works in extremely simple environments. The next step was to train an agent in a more difficult scenario with more observations and a new navigation system. The potential method. The potential method is a great technique to move an agent toward a goal while avoiding obstacles. It can be used online, which means it doesn't need a pre-known environment to compute the path. And it's also really easy to implement. Basically, I built a vector whose direction was affected by 2 contributions: an attractive potential given by the goal, a repulsive potential given by the obstacles. This way, the agent can move toward the goal while effectively avoiding obstacles. A known issue of this technique is that the robot can get stuck while moving in more difficult environments. To fix this, we can apply random movements in order to escape. Or my idea was to train an agent to see if it can autonomously do it. The training gave good results, but for me, it still wasn't enough. I really wanted an agent with strong, solid behavior, able to move autonomously in really complex environments. The potential field is great for obstacle avoidance, especially because it works without knowing the obstacle position in advance. But the downside is that it doesn't always plan the optimal path to the goal. Then I had an idea. What if I combine Unity Navmesh with my potential method? Unity Navmesh is great for planning an optimal path, but it doesn't work for online obstacle avoidance, which is exactly where the potential method shines. So, while I was having this idea, I started writing the code to make it real, and after some attempts and training, here is what I got. A robot trained in an environment with fixed obstacles, which can also move in a structured environment with unknown moving obstacles, or even in a maze. I think this result is truly awesome and that it can significantly improve Unity's standard navigation system. As you can see, the robot moves smoothly using the pathway points as goals for the tracked potential contribution. This could be a great solution for many applications, so I'll keep working on it and turn it into a Unity plugin. I share more details on my Discord server, you can find the link in the description, where I also post scripts and tools I create for my projects and games. Let me know in the comments if you'd like a more detailed tutorial on how to create your own agent. And also suggest a game where I should use ML agents to train an enemy that is impossible to beat. Bye!